Hi folks, this is question 9. So the first question just gives us a square, so it says that the area of the square is 140. So you know that each side of a square is same length. So therefore to get the area you're going to do one side times the other, one side, so the length times the width basically, but the length and the width are the same thing here. So it's just going to be x multiplied by x, so that's x squared is equal to 140. So therefore x has to be equal to the square root of 140. So therefore you get x is equal to 11.8 when you round it off, so centimeters. So that's all you have to do for the first one. Right, to the second one. So there's there's 6 of those all together, 6 of those triangles. So you know that the 6 times the area of the triangle. So I'm going to use a half AB sine C here. That would have to be equal to 140. So therefore 6, and then so because they're equilateral triangles, A and B are going to be the same thing again. So it's going to be half. So x times x. So that's just x squared, and then sin of 60, and that's all equal to 140. So then it's just rearranging around to get everything to the other side apart from x. So like if you multiply the 6 in, you're going to get 3x squared sin 60 is equal to 140. So you're going to divide by, so it'll be 140 over 3 sin 60, and then it'll be the square root of all that. So that'll give you the final answer. So we get 7.3 centimeters. So that's all for part A then. So part B, first part on it, so it says AD is 8. It says that AE is 6. And the other one, ED, is 4. So you've got, so we're just looking at this triangle for this one. So you're going to use cosine rule, so we're just going to write alpha because alpha is part of it. So you've got the 3 sides. So when you're given 3 sides already and it's not a right angle triangle, it's going to be cosine rule. So it's a squared equals b squared plus c squared minus 2bc cos a. So the cosine rule is in your log tables. So here then 4 squared, so this thing and this thing have to be across from each other. That side and that angle are going to be across from each other always when you're subbing in the numbers. So therefore 6 squared plus 8 squared minus 2 times 6 times 8 cos of alpha. So we get 16 is equal to 36 plus 64 minus 96 cos alpha. So we'll get minus 84 over minus 96 is equal to cos alpha. That's just bringing across, because that will give you 100 there, so that's bringing across the 100 and subtracting it and then dividing across by minus 96. So we get 7 over 8 then is equal to cos alpha. So therefore alpha is equal to cos inverse of 7 over 8. So that's what you had to show. Next part then, so ADC and ABC are 90 degrees. So therefore that's a right angle triangle, and so the big triangles are right angle triangles. So we have to find the area of the full quadrilateral. So what we're going to do is we're going to find the area of one of the triangles, one of the big triangles. so the right angle triangle, and then multiply by 2, and that gives us the full area. So I'm going to focus on the top one here, so just look at the top triangle there. So to get the length CD, we're going to work that out. So we know that alpha is cos inverse 7 over 8. So I'm going to use that to figure out what CD is. So from the angle alpha, CD is the opposite and AD is the adjacent. So it's opposite and adjacent. So I'm going to use tan. So I know the tan of the angle. So the angle in this case is cos inverse 7 over 8. I'll just leave it like that for the minute. That has to be equal to opposite, which is what we're looking for, which is x over hypotenuse, which is 8. So I'm just letting x be the side AD, and it's over 8. So you can just bring the 8 across then. So 8 multiplied by tan of cos inverse 7 over 8. And that should work out what x is then. So that's 4.426266 and so on. So that's rounded off, so that's x. So that's the side CD. So therefore I'm just going to use the formula half times base times height. So half times base times height, and that'll work out the area of one of the triangles, and then we'll times that by 2. So I'm going to use 8 and 4.426266 as my base and the height. So it'll be half times 8 times 4.426. Sorry, 4.426. So that would be the area of the triangle then. But remember, we want the area of the whole quadrilateral, so the full shape. So I'm going to times all of that by 2. So I'm just going to times the whole thing there by 2. So the 2 and a half would cancel out if you want to do it that way. But it's easier just probably put it all into the calculator. So we get 35.41 centimeter squared. So that's because it's area. So that's it, that's all for that part. Then we're on to the last one. So so we're given a circle here, so it doesn't really matter about the context of it or what's about the patterns and so on for this part. So we're just given a circle. In the first part, it's asking us to find Q, or it's asking us to show that Q is that there. So you know that any point on the unit circle, because that's just the unit circle, is going to be cos theta sine theta. Now we know that QOP here is 45 degrees. So all we're going to do is we're just going to use cos theta and sine theta, but theta will be this angle here because it has to start there. So that would be 135. So it's just going to be cos of 135 sine of 135, and you can just use radians on the calculator and it'll calculate it for you. So you're going to get minus 1 over root 2 and 1 over root 2. So that's the point. So that's enough to show it then. And that's all you really need to do for the first part. So the second part then, so the point P lies on the x-axis. So it's just basically telling you this information. So what you have to do is you have to find the center and the radius of the circle S and give your answers in surd form. So what that bit in the writing is telling you is that there's two tangents there. So one tangent is going to, so remember a tangent just hits the circle at one place. So the first tangent is going to go straight up through the point P. So it's there, and the other tangent is going to go along by Q. So it will be something there like that. And then that will form the center, because those two tangents will meet, they form the center of the circle. Now the one straight up that goes through P, that's just going to be the line x equals minus 1, because remember it's a unit circle, so P is the point minus 1, 0. So it's just going to go up through that point, so it's minus 1. Now the other one, we're going to find the equation of the line of the other one. So if you just look at that line there first of all, so if I got the slope of that line, and because they're perpendicular, that'll help me work out the slope of the other of the line that I want, the one that goes through Q in the center. So the slope of the line between O and Q, so the slope of the line OQ, this line, so M of OQ is equal to, so it's y2, so it will be 1 over root 2 minus 0 over x2 minus x1, so minus 1 over root 2 minus 0. So that's going to be the same thing then as 1 over root 2 over minus 1 over root 2. So if I take the one on the bottom and I flip it over and multiply, the root 2's will actually cancel out, because it'll be 1 over root 2 multiplied by minus root 2 over 1. So they'll both just cancel out, so we're actually just left with minus 1. So the slope of OQ is minus 1, but that's the slope of that line. I don't want the slope of that line, I want the slope of the one that's perpendicular to it. So therefore I have to do minus the reciprocal, or minus and flip it over. So that's equal to minus 1 over 1. So if I flip over 1 over 1, I still have 1 over 1, and I need to make it minus. So therefore the slope of the line I want will just be 1. So the slope of there's not, so just the tangent, I suppose, or just the slope that I want. So the slope is going to be 1. So the slope is 1, and I know that the point Q, which is on the line, is going to be the one above, so minus 1 over root 2, 1 over root 2. So that's going to be my x1, y1. So I'm going to put it into the equation of a line formula. So y minus y1 equals m by x minus x1. So y minus 1 over root 2 is equal to 1 times x minus 1 over root 2, so plus 1 over root 2. So I get y minus 1 over root 2 is equal to x plus 1 over root 2. So because I have a root 2 on the bottom, I'm going to multiply everything in it by root 2 just to try and tidy it up some bit. So minus, multiply that by root 2, I just get 1 is equal to x root 2 plus 1. So y root 2 is equal to x root 2 plus 2. So I can't really make it much tidier than that. So the place where those, so that's that line there, that's the equation of that line there that I've worked out, that the line that goes through the center. The other one is the one that goes up, and we already know that that's x equals minus 1. So I'm going to use simultaneous equations then. So with that line and with the line x is equal to minus 1. So I'm using simultaneous equations with those two lines. So all I'm going to do is I'm just going to put in a minus 1. So we get y root 2 is equal to minus 1 times root 2. So that's just going to be minus root 2 plus 2. So then y is equal to minus root 2 plus 2 over root 2. So the equation of the centre of the circle then is going to be minus 1 and that thing, so minus root 2 plus 2 over root 2. Now I think it's going to be, you can simplify down this part here into minus 1 plus root 2. You probably don't need to do that, maybe you do. Depends if it said it was in, if they wanted you to put it in simplest form or not. Yeah, so that's going to be minus 1 plus root 2 when it's simplified. So that's the centre, and then the radius will just be the y value. It'll be minus 1 plus root 2 because the point is minus 1 and then that. So the radius is just going to be that distance there, the distance up. So from where you go across to P and then up, so it has to just be the y value. So that's all you have to do. So that's it then. That's that for that question.